Limits of infinite sequences. So you remember sequences, I'm sure. So a sequence is a set of numbers written in a specified order. An infinite sequence may or may not have a limit. Example 1. State the limit of each sequence or state that the limit does not exist. Okay, 1/3, comma, 1/3 squared, 1/3 cubed, 1/3 to the fourth. Does that have a limit? And what is this limit? 0, right? Because what do we got? 1/3, 1/9, 1/27, 1/81, 1/243, one, so we're getting smaller and smaller and smaller. So it has a limit, and the limit will be 0. 2, -2, 2, -2, 2, -2, and so on. There is no limit, right? So it does not exist. Right. It's not going up. Okay. Not going down. It's just alternating between two values. 6, 9, 12, 15. I'm guessing 18, 21, 24.
80.
If it had one, could we put a name to it? Infinite. So we're going to say it does not exist, right? There is no limit. But we know that it is infinity.
Would infinity be a wrong answer to that question?
No. So in this unit, it does not exist, or infinity, if properly used, is an okay answer, right? Now, when you've got one branch going to infinity and one going to negative infinity around an asymptote, you can't say infinity. You have to say does not exist.
Yeah.
Right. It really doesn't. Otherwise, we can name it. Because when we come to curve sketching, that's what we need to know. Well, I need to know that this branch is going to infinity, and this, so when I go to draw the curve, I can draw appropriately. 1/2, 1 2/3, 1 3/4. Hopefully the mic didn't capture that. But 1, what's next? 4/5, 1 5/6, 1 6/7, 1 7/8, 1 8/9, 1 9/10.
Imagination.
What is it?
Not 2.
How is it 2? It's 1. It can't be 2. It's not adding them. It's a sequence of numbers. And the first number is 1 in this sequence, and then every other number is a fraction which is approaching 1. And so eventually it will be 1. All right, so for an infinite sequence of terms. Yeah. Yes. Those things you looked at is whatever. I don't know how you saw it. For an infinite sequence of terms, comma, space, we say that the limit as n approaches infinity of t sub n, right? So the limit of the sequence is equal to L if t sub n is as close as we like to L for a sufficiently large value of n. Okay. So in this case, you're going to end up with like 999 over 1,000. Is that close enough for you? No. Okay, how about 999,909 over a million? No. How about, and so on, right? So the limit as n approaches infinity. So remember, t sub n is t1, t2, t3. So as we take the sequence out forever, it's equal to L if we can get as close to L as we like. State the value of each limit. Okay, the limit as n approaches infinity of 3 to the n. Where's that going? Anywhere? Infinity. Yeah. So we could say it does not exist. Right. Okay. Or we could say infinity, right? So we know it's going to infinity. The limit as n approaches infinity of -1 to the power of n. So just think, what are the first few terms? -1, 1, -1, 1, and so what is it? does not exist, right? You simply have alternating terms between, the terms alternating between -1 and +1. 1/4 to the n. 0. Right? We got that 'cause you got 1/4, 1/16, 1/64, 1/256. -2/3 to the n. Would it? So what is it? Is it 0? Why not? Okay, so it's what? -2/3, +4/9, -8/27. Where are the numbers going, irregardless of the sign? The numbers are going to 0, right? So does it really matter if it's a +0 or a -0? Because what's it getting close? You can get as close to 0 as you want, right? Now, sometimes you might be slightly above, and sometimes you might be slightly below, but 0 is it. Okay, does that make sense? In general, the limit as n approaches infinity of a to the n is equal to 0 if... Okay, so what's the thing? What do we see there? What's going to make this thing 0? You have two examples. Yeah, between -1 and 1, right? So if -1 and 1, although a cannot be what? A can't be 0. Okay. And there's a fancy way we could say this as well, which is that the absolute value of a is, whoops, it's just going to be 1, isn't it? It's not going to be less than or equal to. Okay. I mean, if it's equal to 1, then the thing is just going to be 1s. So a is between -1 and 1, or the absolute value of a is less than 1. State the value of each limit. So the limit as n approaches infinity, 1 over n is 0. -50 over n squared. 0. 10, or what is that, 100,000, million? Million over n to the 4th. All zeros, right? In general, the limit as n approaches infinity of k over n to the power of r, where k is a constant and r is greater than 0, that's equal to 0. Right? It doesn't matter how big the number up top is, right? Because you're going to overwhelm it with the number on the bottom. Determine the value of each limit. 3n cubed minus 2n squared plus n plus 3 over 4n cubed minus... What do you think it is? Just, if you just look at that, does anybody have a... I think that's... Yeah? True. Yeah. So, Chris, how are you going to say? 3 over 4? Yeah. Why? Like, what contribution are the n squareds and the n's going to make? Next to none, right? Like when you get up high enough. Okay, but how do we show this? Right, here's how we show that. So when we have a limit of this form and we want to more formally show, so we look at it, we say, yeah, look, it's 3 over 4, but prove it. What we do is we're going to divide each term, right? And there's what, like 7 terms there. We're going to divide each term by the term of highest degree, which in this case is n cubed. So we're going to divide each term, so it's going to look like this. Equals the limit as n approaches infinity of 3n cubed divided by n cubed minus 2n squared divided by n cubed plus n over n cubed plus 3 over n cubed over, right? We're going to do the same thing down below. So 4n cubed divided by n cubed minus 2n divided by n cubed plus 1 over n cubed. And then we're going to simplify. Limit as n approaches infinity. So we've got 3 minus 2 over n plus 1 over n squared plus 3 over n cubed over 4 minus 2 over n squared plus 1 over n cubed. Now, just to put a little more detail on this one. So we still got that limit, right? So limit is as n approaches infinity of. So now we're going to let the n go to infinity, sort of replace things with n. We get 3 minus 0 plus 0 plus 0 over 4 minus 0 plus 0. Okay, so we actually take the limit. And we end up with 3 over 4. Okay, so there's the formal algebraic way of doing this, right? And how are we going to do the next one? What is the next one? Anybody just looking at it, can you just come up with the limit?
4.
Yeah, I think so, right? Okay, but we got to show this formally, so what do we have to do? So we're going to have to expand that out, right? We're going to have to expand it out. We're going to have to find out, okay, what's the degree of the highest term? We're going to have to divide everything by that highest term and work it through, right? Okay, so limit as n approaches infinity. Okay, what do we got? We got 8n squared, so let's make that 24n cubed. Got minus 2n plus 4n, it would be plus 2n. So plus 6n squared. And we've got minus 1, so it'll be minus 3n over okay, so we expand the top, the numerator. We now say, all right, the highest power is n cubed, so we're going to divide everything by n cubed each term. Equals, so limit. And don't forget your notation, right? Don't just drop the limit sign yet. There is a point at which we actually take the limit, but this isn't it. Okay, 24n cubed over n cubed plus 6n squared over n cubed minus 3n over n cubed over 6n cubed over n cubed plus 5n over n cubed minus, copy what's above, 7 over n cubed. Now, obviously, if this gets asked as a multiple choice question and you can come up with 4, then you come up with 4, right? If it says state the limit, then you don't have to show any work. If it says determine the limit, then this is what you're looking at doing, right? Determine means you have to show the work for this particular question. Okay, 24 plus 6 over n minus 3 over n squared over 6 plus 5 over n squared minus 7 over n cubed. Equals, so 24 plus 0 minus 0 over 6 plus 0 minus 0 is equal to 4. Questions? Pretty straightforward stuff, right? One more. So what's our highest power of n? N to the fourth. So we're going to divide everything by n to the fourth, right? The limit. Oh, first off, what is this? Any ideas? What's it going to work out to? 0. Yeah. Okay. But, you know, formally showing that. What do we got? 2 over n. So the limit as n approaches infinity of 2 over n is 0. And 6 over n cubed is 0. So in the numerator, we get 0, and the denominator, we've got 5. And 0 over 5 is 0. One more in this long lesson, which will be over in 2 minutes. State the value, okay, this time state. State the value of each limit. So, what do you know? All right, well, let's start working it out then. Just because it says state doesn't mean you have to, or it doesn't mean you can't show work.
So just the one on the top is larger. So the top that is going to increase infinitely more than the one on the bottom, which makes it infinite value because it's not divergent.
So where do we go from there? It's going to be 5 over 0, which is dn does not exist. Okay. What kind of non-existence does it have? Is it a positive non-existence? Is it a negative non-existence?
Definitely a negative non-existence, I feel.
Here, really? Yeah, it's positive infinity. Well, I think about it, right? What do you got up top? You're taking something to the fourth power, which is positive, and you're adding 1 to it, so that keeps it positive. And on the bottom, the n cubed, as we approach infinity, is going to be really large positive, right? Minus the I got to subtract enough to make it so it's positive or positive. Okay, what about the second one? Let's just think about what matters here, right? So what matters?
Spoiler alert.
Yeah. Because what matters, right? Really, it's just the first term that matters, right? You know, it's the term of highest degree. So what's 5n cubed cubed? 125 n to the 9th, and then there's some more. What's 2n to the 5th? Oh, sorry, what's 2n squared to the 5th?
32
N to the 10th. And now what can we say?
it infinitely approaches 0.
as it approaches infinity, the limit is 0. So the term on the bottom is a higher degree, right? So what does that mean? Well, we're going to have a term on the bottom, and it'll end up being something over n, and then 1 over n, whatever over n is 0. Yeah. Okay, so because this is the higher degree. Right, that just goes back to the earlier notes again, right? But it's good to work through some, and now you have lots of time to work through some. Right, because we're done.